Hello students. Today let us learn about the next algorithm under the greedy method in the module 3 called as Dijkstra's algorithm. So Dijkstra's algorithm is an algorithm which is used to find the single source shortest path. In the previous two algorithms we have learned how to find the minimum cost spanning tree using the Prim's algorithm and the Kruskal algorithm. In the case of a Dijkstra's algorithm, what basically we are going to do means, so from the single source means we will assume from our given graph, we will assume one particular node or a one particular vertex as a source vertex. From that vertex to reach all the remaining vertices, so what is the actual path? So what is the distance that we are going to find out with the help of this particular algorithm called as Dijkstra's algorithm. So Dijkstra is the name of the person who has invented this particular algorithm. So this algorithm basically accepts two input. So one is G. G is nothing but a graph followed by S. S is nothing but the starting vertex, means from which vertex you are going to assume as the source vertex. So that is basically called as S. So G and S, these two are the arguments. So for this algorithm, so what basically you are supposed to give as an input means you should give weighted graph. You can use any directed or undirected graph. Weighted graph stands for a graph with weights, means edges consists of certain values. Okay, what is the distance between two nodes that you are going to write it above the edge? Okay, that's basically called as a weighted graph. You can use directed graph or you can use undirected graph for this particular algorithm as an input, and you are supposed to specify from which vertex you want to start your algorithm execution. So after reading the input graph, so you are going to read, so what is the source vertex. So output is the shortest path from S to all other vertices. S stands for source vertex. From the source vertex to reach all the remaining vertices, what is the shortest path. So as we know that in our graph, okay, if you consider one particular node as a source node, from that node there may be possibility of one or two nodes directly we can able to visit, means there will be a directed edge. So here we are going to form how to find the indirect path, means even though there is no direct path from one node to another node, so how to reach that particular node with the help of other nodes as an intermediate nodes we are going to reach it. So that we are going to learn with the help of Dijkstra's algorithm. So what basically we are going to do means, first and foremost thing, we will make use of some arrays here. So we will make use of some local arrays. So these are responsible for each v not equal to s do, means v stands for every vertex we are going to consider apart from the source vertex. You need to consider all the other vertex. You should initialize the first is equal to d of v is equal to distance of the particular vertex from the starting vertex. From the source vertex, if you have a directed edge, definitely you are going to write that particular value. If you don't have a direct edge, you are going to write here as infinity. So either you are going to specify the value or you are going to specify it is undefined or infinity, means there is no directed path. So similarly, d of s is equal to 0. This is mainly representing, so initially the source vertex is also 0, we are not going to visit. Then s is equal to 5, nothing but this S is all the set of vertices. None of the vertices you have visited, none of the edges you have selected, none of the path you have come across with. So here you will be creating your own priority queue with respect to all the vertices. That information you are going to record, means from which vertex to which vertex I need to start. Because first and foremost thing, we are going to find what is the minimum edge. Then we are going to find, based upon this you are going to have certain priority. So while q not equal to null, means until this null, means all the vertex are visited, we will try to extract the minimum value. So first we are extracting the minimum value, then we are considering that particular vertex. Then after considering a particular vertex, then again we are going to check is there any cycle also, that also you are going to check, and if there is any minimal path, that also we should identify. Here no need to form or check graph should be acyclic only, nothing like that. So we are going to find the path in such a way that, so we will have certain comparison. If of d of u plus w of u comma v, nothing but whatever the vertex you have visited. So from that vertex, can you able to reach to the next vertex by considering that as a intermediate vertex? So if that distance is less than the actual vertex, then you consider that distance. Suppose to reach Majestic from Banashankari, so you can have any number of paths. So different path you might be using. So which is the shortest path you are going to choose? Initially I am going to say that metro is my convenient, so I will take the distance of the metro. So from Banashankari to Majestic. So if you have any other alternate path, okay, so any other shortest path, then that vertex will be considered, then that path will be considered. So that is what we are going to learn with this particular thing. So d of v is equal to d of u plus w of u of v. Means if that condition is true, then we will update that. So this we will learn with the help of a problem. So finally you are going to return which are all the vertex are selected, what is the importance of it and all these things. So finally you are going to end the Dijkstra's algorithm. Okay, so let us see how the algorithm is applied to the problem. Then we will see how to run the program. Okay. Okay. Now, just now we have discussed about the algorithm. Now let us see how to apply the same for the Dijkstra's algorithm. So for our given graph. So let us consider a simple graph here. Okay, with 6 vertices. The same graph which we have considered for Kruskal as well as Prims. The same algorithm I have considered. Same graph we have considered here. Okay. So now what basically you are going to do means, first initially length of dv of the shortest path from source S. So I have considered source vertex as A in this particular graph. From the vertex A to reach B, so I have the direct edge with a minimum cost 3. Similarly, to reach the vertex F, I have a directed edge with a cost 5. Similarly, to reach from A to E, I have a directed edge with a cost 6. So now A to C, if I want to reach, I don't have a direct path. So I need to find the alternate path using either A to B or A to F or A to E. Okay, so only possibility to reach here is with minimal distances A to B. Then from the B you can able to reach to C, because 3 plus 1 it is 4. Suppose if you choose the path A to F, 5 plus 4 it will become 9. So now the cost is 4, here the cost is 9. So in this case, so this is what you are supposed to find with the help of Dijkstra's algorithm. So that let us see how to find it. Initially, so d of a is equal to 0, db is equal to infinity. All the other vertex distance we are going to mention it as infinity. Means initially we don't know any of the distances. Then path between from source vertex to all the remaining vertices we are initializing it to null. So once after this, we will go for plotting a particular table. So in the table we will be having 3 vertex, remaining vertices, distance and path, then graph. We are going to plot the graph correspondingly. Okay, first let us consider A half hyphen comma 0. Hyphen stands for from which vertex you are reaching A. Since A is the source vertex, you are putting hyphen. It indicates that since it is a source vertex, so there is no other distance previous vertex from previous vertex we are visiting this. So we will not consider it. Then remaining vertices and distance. So only B, E and F are having the directed edges. For other 2 vertices C and D, you are supposed to find what is the path. Okay. That's the reason we are putting hyphen comma infinity. From which vertex you are going to visit that vertex, don't know. Okay, that's the reason. So similarly, distance you are going to list it out. Same value what you have listed as a second argument, you are listing here. Then path of A is equal to A only. Means since it is a source vertex, there is no other node to reach that particular node. Then path of the B is equal to A comma B. To reach B, you need to start from the vertex A and you need to reach B. So that's why I written P of D is equal to A comma B. Then DC means to reach the vertex C, still you have not found the path. Similarly, to reach the D, you don't have a path. Similarly, to reach the vertex E, you have a path from A to E. Similarly, path F. So among which is the minimum edge? So minimum edge is A to B. So this edge you have selected and you have plotted the graph. So once after this, from the B, already A is visited and B is visited. From A or through B, can you able to visit any other remaining vertices that we will list out. So remaining vertices are C, D, E and F. So since already B is visited, I can able to reach C with the help of B. Means from A to B I will travel first, then B to I can travel to C. So 3 plus 1, that's why I am writing the distance separately. 3 plus 1. Okay, we are listing out all the remaining edges. So among which is the shortest distance? B to C is the shortest distance. Means A to B, B to C. Total it is 4. So we have considered. Here we are writing the path. You can observe here. Path is A to B, then B to C. You need to travel. Okay. A to B, then B to C. The total cost here is 4. The total distance you need to travel here is 4. But you need to traverse through A to B, then B to C. So this is going to act as intermediate vertex between the vertex A and vertex C. So once after considering the vertex C, go for checking the remaining vertices D, E, F. So I can able to reach D from the C with the distance 4 plus 6. Okay. So D was not visited previously. That's why hyphen comma infinity. So now C, with the help of C, 4 plus 6. E is having direct edge, F is having direct edge from A already. Okay, so among which 5 is the shortest value or minimal value. So we are going to consider the next vertex as F. So with the cost 5. In the next step, so after considering the F, so remaining vertices are D and E. So among which E is already having the directed path with the cost 6. So there is no other path which is having the lesser value. So we will ignore it. Means only we will consider directly. We will not go further. So the path here is A to E, direct path here. We are just listing out the direct path. Okay. So far you can see D of C comma 10. So this is the A to B you need to travel, B to C you need to travel, then C to D you need to travel. Okay, to reach that particular vertex D. Okay, with the cost 10. Then E is considered in this particular graph. So vertex E is added into the graph. In the next line, in the next iteration, so E is considered. So left out or remaining vertices is only D. Is there any other path you can able to reach D apart from this particular path? Let us see that. So if it is giving the same value, so we will consider the same path. If it is giving the more, so let us take the graph. What is the graph? Okay, so even if you traverse from A to F and F to D, so 5 plus 5 it is 10. So here also 3 plus 1 4, 4 plus 6 10. So there is no change in the value. As per our algorithm, there is no change in the value. That's the reason. So we will consider this path only. Either you can consider A to F and F to D. Both doesn't matter. Okay. So but cost is equal to 10. It is fine. So then we are listing out the path. So this is our output. In which particular path you are going to traverse to reach a particular vertex from source vertex to remaining vertex. This you are supposed to list out. Based upon this, you need to plot this output graph when you execute a program. I'll just recollect whatever we have discussed. So first, basically what you are going to do, you will consider one graph as an input graph. So from that input graph, you will assume one vertex as a source vertex. You will read that input from the user side. Which vertex should be the source vertex? So from that source vertex, what exactly you are doing means, so in this particular graph, just take a particular graph. Source vertex is A. From A, I need to reach to B, C, D, E and F. To all other remaining vertices, I need to reach. Okay, to reach all the remaining vertices, so I need to traverse directly if I have a directed edge. If I don't have a directed edge, I need to find the alternate path by traversing from one node to another node by considering some other node as an intermediate node. Okay, so if I want to traverse from A to C, I don't have a directed path. That's why first I will travel from A to B. From B, I will travel to C because it is giving the minimum weight. So 3 plus 1, 4. So in that way, you are supposed to find. So for that, we will just have the look of it. So finally, you are going to print out the path. So in which particular path you have traversed to reach all the remaining vertices. So once after considering all the graph, so your algorithm stops because there is no remaining vertices. Your algorithm is going to get stopped. So what my suggestion is, take the below shown graph. Okay, so take the below shown graph, apply Dijkstra's algorithm for the given graph. Just take a graph. So plot this particular table and you will go across with this particular path. So you can able to find the minimum path to reach from one source vertex to all other remaining vertices. So here I have considered B as a source vertex. Here again I have considered A as a source vertex. So you can consider any other graph. So similarly we have two more graph. So these two more graph also you can able to consider. Here I have a directed graph. So this graph also you can able to consider. This is undirected graph and directed graph. Our algorithm, Dijkstra's algorithm accepts either directed graph or undirected graph. So let us come to the conclusion. So what is the conclusion here means, basically your Dijkstra's algorithm limitation is it doesn't work for negative weights. So you can't put the negative values here for the edges. Okay, then applicable to both directed and undirected graph, use unordered array to store the priority queue. Efficiency is theta of n square to store. Efficiency of the priority queue is big of e log v. This we will discuss in the later session. Thank you.